Ever wanted to be an astronaut? Imagine heading into the ice zone, the frigid, dark realm beyond the orbit of Saturn. To travel here means undertaking a voyage of epic proportions. Think of this as your personal travel guide to the outer solar system. First stop, Uranus. At first glance, the seventh planet from the Sun appears as an unmeasurable ball of green-blue fog. But slip below Uranus's icy veil, and you encounter a world seemingly without end. Because this is a planet made almost entirely of gas. Hydrogen, helium, and a splash of methane that gives the planet its color.
It's actually very difficult to describe to people what it feels like the interior of these gas giant planets because it's so far from our terrestrial experience.
The third largest planet has at least 13 rings. But unlike the broad bands of Saturn, these are thin and dark. No one's quite sure how they formed, but they could be the result of collisions between its small army of at least 27 moons. But Uranus's most striking feature is its lopsided tilt. It's the only planet in the solar system to orbit on its side, resembling a giant bullseye. How did it end up this way? The answer may surprise you.
I'm fascinated by Neptune and Uranus because we know so little about these planets. We've only ever had one spacecraft visit them, and it was a very brief flyby.
Astronomer Heidi Hamill is driving to the ice giants. Well, about as close as you can get to them on planet Earth.
The most exciting thing about Uranus is that it's completely tilted over on its side. Its atmosphere changes radically depending on the season. And it has a really interesting thin ring system. So that's a cloud, and these, of course, are the rings. It's a nice image of Uranus.
Although separated by 1.6 billion miles, one of the world's highest telescopes is watching the planet spring into life.
Uranus has been going through a very special season that we call equinox. The north polar part that's coming into sunlight for the first time in 2 decades is turning on with all kinds of dynamic cloud activity, none of which was expected or predicted. So it's very exciting to get this data and basically be rewriting textbooks about the Uranus system right now. We're very happy astronomers.
For the first time, this far-flung outpost is being seen in a new light. And when it comes to image, it's not a moment too soon. That's because, for most of us, Uranus is the butt of a big cosmic joke.
I pronounce it Uranus. I think people are embarrassed by Uranus.
Uranus, yeah.
I pronounce the planet's name Uranus, which is very likely closer to the original pronunciation of the name of the god after whom it was named.
If you think Uranus is a funny name for a planet, then you may prefer its first name, George. Discovered by William Herschel in 1781, he christens his new find Georgium Sidus, after the King of England, George III. But the custom of naming planets from ancient mythology prevails, and Planet George is no more. And it's very likely that Uranus would have remained nothing more than a green-blue blotch at the end of a telescope if it wasn't for a really bright rocket scientist and a little bit of luck.
And a lot of people were saying back in the 60s that it would be impossible for us ever to explore those distant planets, too far away.
As an intern at the Jet Propulsion Laboratory in California, Gary Flandreau is given the task to investigate a journey to the outer planets.
So I started drawing pictures of the solar system, and in that process, I noticed that all of the outer planets turned out to be about the same alignment relative to the Earth in the late 70s. So I saw that I could almost draw a ruler between Jupiter, Saturn, Uranus, Neptune. Pluto was not cooperating, but that seemed not to be a worry.
This mathematical sleuth work reveals a rare window where the planets are perfectly aligned for a visit.
There's an opportunity every 176 years for a single spacecraft to fly by all 4 giant planets. That was 1977, and so we created the Voyager mission to start on that journey.
A complex package of experiments called Voyager is designed to take the first thorough, close-up look at the giant outer planets.
In an extraordinary feat of engineering, teams build 2 spacecrafts in just 12 years and push the existing global network of ground stations to new heights.
The outer solar system's called outer for a reason. It's a long way away.
The rest of the solar system beyond the asteroid belt is really where it's at. And so that's what Voyager did. Voyager showed us what was out there.
On board, there's even a gold record containing a greeting from Earth, should the spacecraft encounter any friendly aliens.
Hello from the children of planet Earth.
Bonjour tout le monde. Konnichiwa. O genki desu ka?
Hola y saludos a todos.
We knew the Voyagers were going to be the first to reach interstellar space, so we felt that this was sort of an announcement from Earth that we were now able to send a message away from our solar system into orbit around the center of our own galaxy.
Launched a few weeks apart in 1977, the twin Voyager spacecraft embark on their epic journeys, known as the Grand Tour.
It was a first, it was historic. Just being part of the whole mission, being part of this tremendous enterprise, the first time in human history we are seeing these bodies up close, was a thrill.
What would it be like to follow in the footsteps of Voyager? To experience one of the greatest journeys in space exploration? Sending a robot to the ice giants is one thing. Sending humans billions of miles across the vastness of space is something entirely different.
Getting to the ice giants is tough.
I can imagine what my children would say if I told them I was going off on a 24-year mission to the planet Neptune. I don't think they'd be happy with that.
Any journey to the outer solar system would begin here, on the launch pad.
Launch is one of the riskiest times for every mission.
You'll also need a spacecraft. This is the future of space travel. The Orion.
This is a mock-up of the Orion cockpit, and so we're going to launch on this vehicle and see what it's like to take off and get into space.
Astronaut Lee Morin is no stranger to space flight. He's logged nearly 300 hours in orbit, and now works on the Orion cockpit design.
It's a moment that no one takes for granted. You just sort of hold your breath.
4, 3, 2, 1.
Our rocket to the ice giants blasts off.
And liftoff.
We've just lifted off and we've cleared the tower now. And right now I'd be strapped on my back, nestled in tight, and the G's would be starting to build up on me. But to me, it felt like someone was sitting on your chest. It took me back to being on the playground and having the bully sitting on your chest and beating you up. I mean, that's what it felt like.
So you're on your way to Uranus and Neptune, following in the wake of Voyager.
It'll take us about 8.5 minutes to get to space. You can see we're getting higher in altitude. The sky is getting darker.
But what will a 24-year mission really be like? What will you see? What will you do? And how will you ever survive?
Should be coming up on terminal send ignition.
Planning a vacation to Uranus? Time to study up on what you're about to get into. 63 times larger than the Earth. Here, you'd be lucky to celebrate a single birthday. The planet takes 84 years to make its way around the Sun. Uranus and sister Neptune are known as the ice giants because of their frigid outer atmospheres, supercooled to minus 355 degrees Fahrenheit. But the biggest, most obvious feature about Uranus is its crazy tilt. However, it wasn't always this way.
The traditional explanation was that while Uranus was forming, it may have been hit by a larger chunk of accreting material than normal and actually knocked it over on its side. The problem is when you do the maths on this, it doesn't work. It's very, very difficult to get a large enough body traveling fast enough to be very credible at knocking Uranus over on its side.
Rather than being pounded, it's now thought that Uranus may have been swept off its feet by the gravitational tugs of its giant neighbors.
Uranus's tilt actually results from rather complicated interactions with Saturn, Neptune, and Jupiter even. All of these planets do have gravitational effects on one another, and the effects are more subtle than we used to think, and it's dynamics, not a big smack in the face from a large impacting planetesimal.
Imagine if Earth were like this, tilted on its side. Equatorial jungles would turn to ice. In summer, the Arctic Circle would evaporate and become a steaming tropical paradise. What would be north? What would be south?
You can get into very long, heated discussions at a bar with astronomers about what the North Pole of Uranus is. So don't go there.
If tilting the Earth causes weather chaos, what is it like on Uranus? Do the clouds spin on the same axis as its tilt, or differently? Scientists have many questions about the first ice giant. When Voyager journeys to the outer solar system in the 1970s, it beams back astounding images of Jupiter, Saturn, and many of their moons.
The wonderful thing about the Voyager mission, we saw so many things for the first time, and they were all so different, so diverse and distinctive.
Being there when the images are coming in makes you feel like you're on the bridge of the Starship Enterprise, because you really feel like you're there. Those are just your sensor screens, and you're getting reports back from these alien worlds that you're taking a look at.
Who could ever have enough pictures of Saturn's rings?
So what do Voyager's cameras reveal of Uranus, the lopsided planet?
Well, Uranus was a real enigma for us. So we didn't know what to expect.
In 1986, after a decade of traveling through space, there are great expectations for the seventh planet from the Sun.
From the Earth, it looked kind of bland, and quite frankly, from Voyager, it looked kind of bland, too.
The images of Uranus were a little bit disappointing.
It's a very bland planet with very few clouds.
Not much going on at Uranus.
These are the first images of Uranus, taken from Voyager 2. The planet appears as still as a pond, with no cloud detail at all, and it's silent.
We did not hear a whisper from Uranus before the Uranus encounter.
Unlike Jupiter, whose magnetic field roars across the radio waves, At first, Uranus doesn't make a peep.
Part of that was because the radio source was on the other side of the planet where the strong magnetic fields are, and they were beamed away from the spacecraft.
Voyager discovers that Uranus's magnetic field is wildly off-kilter.
You have one hemisphere with very strong magnetic fields, stronger than the Earth's magnetic field. You have another hemisphere, the one pointed towards the sun, with very weak magnetic fields.
Planetary magnetic fields require the movement of charged particles. On Earth, this occurs in our molten iron core. So what's driving Uranus's magnetic field? There's more going on here than meets the eye. Time to start exploring.
Roger, roll.
Probe program initiated.
From orbit, Uranus gives little away. But plunge below its placid-looking clouds, and you encounter a world that's anything but.
So let's imagine I was riding an atmospheric probe that's being sent down into the planet Uranus.
Open your spacecraft window here, and you'll quickly feel where the ice giants get their name. In the upper atmosphere, frozen crystals of methane mix with hydrogen and helium.
We might pass some of these towering anvil clouds that we know are there, and as we looked at those, we would look for the lightning, we would listen for the thunder that accompany them.
Free falling here is like descending into a giant green gelato. But the deeper you go, the thicker and hotter the atmosphere. Temperatures heat up to thousands of degrees. Heat left over from when the planet formed.
Eventually, the pressure just builds and the gas becomes basically a fluid or a liquid. And there's no real transition, it's just a continuous increase in pressure and density.
Keep descending, and you'll soon start to boil in a seemingly bottomless sea. More than 2,000 times deeper than the Pacific Ocean. Somewhere down here, a little more than halfway to the planet's center, Uranus's lopsided magnetic field flutters into life.
If you could see down to the surface of the dynamo core where the field is generated, what you might see is parcels of fluid moving about, and they're generally so conductive that those parcels of fluid would drag field lines with them.
Why Uranus's magnetic field is generated here and not in the core, no one really knows. No person or robot has ever been down here.
If we could get even further, we might get to a core, but we're not sure. Isn't that interesting? We aren't sure if Uranus has a core.
Down here, one thing is certain. With a planet load of water and gas on your back, and in temperatures of more than 4,200 degrees Fahrenheit, no life, or robot, will last long.
There'd be no chance of surviving under those conditions. A probe going into the atmosphere would eventually actually evaporate and become part of the atmosphere that it was studying.
Not enthused about the prospect of being crushed and boiled alive by a giant ball of gas? Don't worry, there's still plenty more to see and do. Cruise above the skies of Uranus and take your pick of 27 moons, most named after characters from Shakespeare.
If I were to take a tourist trip to the Uranus system, I would go to Miranda.
Only 290 miles across, Moon Miranda is about as wide as the state of New York, but the geography here is stranger than anything on Earth.
It's an interesting sort of jigsaw puzzle moon. It looks like it's been put together by a potter with not paying too much attention to his materials. It's got chunks of this and chunks of that that sort of look like they're slapped together. And frankly, we still don't really understand Miranda too well.
And while you're here, it's hard to ignore Uranus's other tourist attraction. Its collection of 13 razor-thin rings.
Uranus's main rings are very tightly confined with a lot of space in between them, sort of like a series of hula hoops, increasingly large hula hoops moving away from Uranus.
How these rings form, no one's completely sure. But they could be the result of a cosmic demolition derby.
The 5 major satellites of Uranus are in pretty regular orbits, and they are stable. But some of the other objects, especially the outer satellites of Uranus, scientists have been working on computer models that show they do frequently collide. And if they get too close to Uranus, they could break apart. And of course, Uranus does have a very complex family of rings that we believe is broken up satellites.
For the planet that's always been the butt of everyone's joke, perhaps it's only fair that it has the last laugh. That's because Uranus's best view is its rear end.
As we were flying out from Uranus, we were looking back and looking at the rings that we call high phase angle. It's equivalent of if you have a dusty windshield and you drive into the afternoon sun, the dusty particles light up. So too in the Uranus system. I remember sitting there as that picture came down, line by line and played out, and just the joy that, oh my goodness, we didn't know there was something quite so spectacular to see there at Uranus.
Take a good last look, as there's nothing more to see for 3 more years, until you arrive at Neptune. Make sure you have plenty to keep you busy. Being cooped up in a tin can is sure to play tricks on your mind.
Out in space, separated by such great distances, you need to start thinking about the psychology of the space environment. You're going to be in a close, confined environment with almost no privacy. Death is always going to be just a whole thickness away, and you have to start thinking about how you stop your crews going crazy.
The possibility of going crazy is something these space travelers know all about.
Congratulations to the explorers, to the mission organizers, and to the scientists.
The heroic welcome is to celebrate their return from a 105-day space mission. Only thing is, they haven't traveled an inch.
The Mars 500 program is a simulation project of a mission to Mars. What we would like to do is to simulate the time delay, the confinement, the psychological and physiological aspects.
Sealed away in this Moscow warehouse, the crew lived every day as if they were on a long-haul space flight for real. Watching closely, a team of psychologists and doctors who monitored every aspect of their mental health.
It was not always easy to stay in such a confined area for such a long time, so you always felt kind of limited, since the space is just limited. You didn't have the sunlight, you didn't have the nature, so this had quite an impact on the crew. So.
The psychological effects from this mission of the mind are still being analyzed.
I would say that the 6 crewmates are working well together. Also considering that we have a French guy and a German guy on ESA side, and then 4 Russian guys. They have a very good relationship as far as understood.
No one seemed to go crazy on this mission. But on a voyage to the ice giants, if the isolation doesn't make you insane, the menu might.
in order to keep us healthy, and we hardly had any fresh fruits or vegetables. We ate this baby food here, which might not be a usual food you have in your usual life, but at least it's kept us healthy, and I didn't even think it tasted too bad.
105 days eating baby food is certainly an achievement. But who is going to do that for 24 years? Moving out from Uranus is its ice sister, Neptune. Another mysterious ball of frigid gas. And out here, there's proof the solar system still has a few incredible tricks up its sleeve.
Houston now controlling.
Well programmed.
On the approach to Neptune, be prepared for a surprise. Because at the end of the solar system is a reminder of home, a second blue planet.
Unlike Uranus, Neptune was immediately beautiful, especially when we started to produce color pictures, because it had this blue-green atmosphere and these white clouds floating in the atmosphere. So you couldn't help, at least I couldn't help but be reminded of the Earth.
At 30 times the distance of the Earth to the Sun, the star appears not much more than a glimmering point of light. Out here, the days pass quickly, each 16 Earth hours long. But you'll need a thick calendar with around 90,000 days to a Neptunian year. That's 165 Earth years to orbit the Sun. Like its neighbor, Neptune is a giant ball of hydrogen and helium, its color courtesy of a bit of methane. But it's so blue here that some other chemical mixture is at work.
In fact, there's something in the clouds of Neptune that is causing its vivid blue color, and we don't know what that is yet. It's one of the mysteries that we're trying to solve by studying Neptune with our telescopes on the ground and in space.
There's a little bit less scattering in the atmosphere. There's a deeper methane layer, so even more of the red is absorbed out of the atmosphere. It makes Neptune really a blue planet instead of a green planet.
And that's not the only mystery. Something is driving Neptune's wild winds, the fastest in the solar system. And why do Neptune's spots vanish almost as quickly as they appear? Most amazing of all, Moon Triton has a secret that has all the experts wondering.
So as we were approaching Neptune and it was getting larger and larger in the TV screens in the Voyager project area, the thing that really got us going very rapidly, we noticed that Neptune had something that Uranus didn't, which was a big spot in its atmosphere.
Voyager saw several spots. One of them, the biggest one, we imaginatively called the Great Dark Spot.
It kind of was like watching a blob of ink in swirling water.
About the size of Earth, the Great Dark Spot is actually a massive hole, a window to the darker clouds below.
So a swirling storm that cleared out a hole in the clouds, allowing us to see down to deeper layers. It didn't give the appearance of being stable. It sort of gave the appearance that at any moment it could fall apart. And so we weren't all that surprised when, within 5 years, it had disappeared.
In 1994, when NASA turned Hubble, its orbiting telescope, towards Neptune, its Great Dark Spot had vanished.
So this planet just changes its spots. Leopards don't, but Neptune does. It dramatically changes its spots on timescales of just 5 years. That was a surprise that Neptune changes so quickly. It's a different kind of planet.
Since then, other spots have come and gone. No one is sure why, but it could have to do with Neptune's wild equatorial winds. take a leap into Neptune's atmosphere, and you'll be surfing the fastest skies in the solar system. This wind tunnel in Los Angeles is barely a ripple of air compared to Neptune's winds. Because on the last planet in the solar system, winds roar around the equator at nearly twice the speed of sound.
What drives the weather is, there's two things. One is the sun, just kind of like the Earth, although the sun is pretty weak at Neptune. And then Neptune has some leftover heat, and the heat comes out as warm gas. When the planets formed, all this material came crashing together, and that crashing together generated heat. And some of that heat is still there, buried down inside Neptune. And when the heat inside Neptune comes out, you get updrafts, and that drives the jet streams, and the whole thing is a big weather machine.
With no bulky land masses to stop them, Neptune's jet streams keep going and going.
It could be that the winds on Neptune just grew over time. They kind of developed over time to be very rapid, even though the energy that started them off was very feeble.
But what's underneath the sheath of Neptune's ferocious winds? Does the planet that takes its name from the god of the ocean live up to its reputation? Can you really set sail on a Neptunian sea?
Just about everything about Neptune and its system relates to water in some way.
One thing most experts agree on is that Neptune has plenty of water. However, exactly what form it takes is less certain. But it's something almost everyone has an opinion on.
There's a lot of water on Neptune, but it's down deep, and it's probably too hot to be a liquid right now.
Down here, it's like soaking in a planet-sized steam room. Gas is squeezed into a liquid.
Not an ocean, but sort of a strange mixture of atmosphere heavily laden with denser and denser liquid materials as the pressure got higher.
If there were an ocean on Neptune, it would be very deep inside the planet. It would not be on the outer part of the planet where we could put a spacecraft or a boat like this.
On Earth, the combination of heat and water is essential for life to exist. So what are the chances of meeting any locals here?
You've got some warmth, you've got hydrocarbons, you've got water. You could well have developed some life form. Somehow I suspect it's not going to be particularly sophisticated, but who knows? Maybe there are big stingrays swimming around deep in the ocean.
Not a fan of the deep? Don't worry. Like its icy neighbor, there's plenty more to see and do without getting your spacesuit wet.
Those of us who were interested in rings got teased mercilessly as we were on approach to Neptune, because it wasn't clear Neptune had rings per se. They were just impartial arcs, is what the mindset was. That was our idea. And then finally, when we got there, we did find Neptune had diffuse rings, complete rings, but also these rather opaque ring arcs.
Neptune's rings may not be the prettiest in the solar system, but they're still worth a snapshot or two.
Neptune's rings are clumpy. There are sections that are very bright and sections that are very thin.
These particles are very dark. They might be water ice mixed with some organics, or maybe just organic material. They only reflect a few % of the sunlight that they receive, so very, very dark, very different from Saturn's bright, icy rings.
It's thought these gangly ring arcs are kept in check by the gravity of tiny satellites, known as shepherd moons.
This was something, in fact, I was personally involved in trying to understand how the arcs were there. And we found that they were being anchored by one of the moons, the moons that, in fact, Voyager had found in the ring region.
As a ring scientist, I'd be very interested in collecting some souvenir ring particles, and so I'd probably try and, get a space-worthy jet ski equivalent and then go to explore the rings of Neptune.
Neptune's ring arcs are one of a kind in the solar system. But the real showstopper here is Neptune's moon, Triton. Just getting to Neptune means putting your life on hold for 24 years. That's a lot of in-flight movies. But what if you could literally put your life on ice? Suspended animation has long been a favorite topic of science fiction. Like the clients of this cryogenic facility in Arizona, the space traveler of the future could well become a time traveler.
The purpose is to hold them in a state of suspended animation until such time as they can be reanimated.
Inside these canisters are the frozen remains of 88 people, all hoping for a second shot at life. The problem with cryogenic suspension is that it's not very user-friendly. You have to die first. But for the space traveler of the future, that could all change.
So you could put them in a state of suspended animation, put them on a spaceship, and months or years later wake them up at the destination. So they wouldn't have to be alive and conscious and eating and doing all the other things that you have to do when you're alive.
Already, scientists are working on ways to slow down metabolism.
About 2 hours after we have injected the AMP, and the mice now are in deep hypothermic state.
The mice, who don't normally hibernate, are injected with a nucleotide that inhibits thermoregulation. A state of hypothermia is then induced by lowering their core temperatures. After around 2 hours, the rodents stir.
So what happened now is the mice is now in an arousal state.
They're a little sleepy at first, but completely unharmed.
I hope that within 10 years, we can run some of this in a human trial somewhere down the road.
Could this really be the future of space travel? If we're to undertake the incredible journeys to planets like Neptune, suspended animation may be the only practical solution. Will a trip out here to Neptune really be worth the time and fuss? Well, some planetary scientists think it could be, if only to visit Triton.
Well, I remember the night we flew over Triton. We stayed up all night because I think the flyby happened early in the morning, and it was just so unusual.
Oh boy. Triton is an extremely complex moon that we understand only in part.
The largest of Neptune's 13 known moons, Triton is covered in a thin layer of ice. Its surface rippled and textured with features seen nowhere else.
Triton has pits on part of its surface that's called the cantaloupe terrain because it looks a lot like the surface of a cantaloupe.
The other interesting thing about Triton is that it has a violent past. It was almost certainly captured by Neptune. The reason we were certain that it was captured is that it is rotating. It is going around Neptune in the opposite direction.
And hiding in these fuzzy pixels is Triton's biggest party trick of all. Voyager's camera captures geysers that shoot high into the air.
It was found that there were jets coming off the polar cap of Triton, and these things were going some 15 kilometers or 10 miles into the air and then taking a 90-degree turn as they hit a prevailing jet in this very, very thin atmosphere.
We're not sure if these plumes are powered from the internal heat engine of Triton, or are they actually powered by the very weak and faraway sun, which might be causing some local evaporation to make these plumes?
These are Triton's ice volcanoes that purge an inky cocktail onto the gleaming surface.
When we see black stuff in the outer solar system, we think organic material. Organic does not mean life or plants. Organic in our talk means carbon bearing.
These are the building blocks of life. So we think that that dark material may be prebiotic chemistry going on. Not life itself, but the precursor to life.
So here we find even our last port of call, Triton, you know, cold, cold, cold body, and yet there is this activity going on.
So, you finally made it to the outer solar system, following the epic journey of Voyager 2. After 12 years of traveling, what do you do on a short stop before turning around and heading back home?
Well, if I were going to the outer solar system, going to Uranus, I think first of all I'd want to orbit Uranus a couple times just to take in those rings, because I think that, you know, rings are one of the most beautiful sights in the solar system.
I'd go picnicking on Triton, and I'd make sure that I took some really warm clothes with me and some binoculars, because sitting on Triton and looking at this beautiful blue Neptune hanging up there would be quite a trip, actually.
And then I'm sure I would sit waiting for Old Faithful to go off, however long that was going to take.
By looking at the other planets in our solar system, we can learn about planetary systems. And I think that Uranus and Neptune have stories to tell us if we can only hear their stories.
They are the ice giants of the solar system. Two fathomless worlds, impossibly remote and unimaginably hostile. Uranus, the planet with the funny name, but with hidden beauty. And Neptune, a seemingly watery world with a spouting moon. It's unlikely humans will venture out here anytime soon. Until we do, who knows what other secrets await discovery in the ice? That's the beauty of traveling the solar system. It's full of surprises.